In this video, we are going to try to graph a rational function and hopefully make the explanation of graphing rational functions a little more clear. Now, to graph a rational function, if you look at various textbooks, they will give you however many step procedures to do this. Trigstead, for instance, uses a 9-step procedure. Miller uses an 8-step procedure. I don't remember what Blitzer has. But the steps and the number of steps really aren't important. What they are going after is the key features. So what I like to think about with the graph is what are the key features? And these really come in 3 flavors: asymptotes, intercepts, and holes. There are 3 kinds of asymptotes: vertical asymptotes, horizontal asymptotes, and slant or oblique asymptotes. We can have as many vertical asymptotes as we want. We can only have one horizontal or slant asymptote. We cannot even have one horizontal and one slant. It's one or the other, but not both. Intercepts are either x or y. And then there's only one way that you can have a hole. And any of the multi-step procedures that they'll talk about in textbooks are really about getting these features along with, I guess, a fourth that doesn't happen very often, which is called symmetry. And you don't have to go in any particular order. So let's look at this one. F of x equals 2x squared minus 8 over x squared minus 3x minus 4. And so let's see what we can find. Whenever we have a rational function, it's always good to think about its domain. And we get the domain by setting the denominator equal to 0, solving, and getting rid of these values. This is a quadratic, so we'll solve it by factoring. This should be x minus 4 times x plus 1. So we get x is 4 and x is negative 1. We don't want either of those, so our domain would be negative infinity to negative 1, unioned with negative 1 to 4, unioned with 4 to infinity. Now, the nice thing about finding the domain is that these problem areas, when x is negative 1 and when x is 4, can only either give us a vertical asymptote or a hole. It has to be one or the other of those, and it cannot be both. It is one of them or the other one, but not both. And we'll find out which one it is by reducing the radical function, which we should go ahead and do at this point. Once we reduce it, all the rest of these should come out fairly quickly. Well, we reduce by factoring. So the top gives us 2 times x squared minus 4. Bottom we just factored right here, so let's not even bother to do any extra work. X squared minus 4 can factor, so we will factor it. And we have no common factors, so we are done reducing this rational function. Since there are no common factors, both of these domain problems that we found are vertical asymptotes. So we have our vertical asymptotes complete. If we had had a common factor and had removed one of these factors, then that particular domain issue would have been a hole instead of a vertical asymptote. But we didn't have that, so we don't have to worry about it. So I have these as my vertical asymptotes. And you know what? As I'm finding these key features, let's just go ahead and start graphing them. So we've got two vertical asymptotes, which means they are vertical lines when x is -1 and when x is 4. I like to do red dotted lines. Either way, you should do dotted lines, whatever color you make them, just to make it clear it's not really a part of your graph, it's just a feature that lets you see what's happening with the graph. Horizontal asymptotes. We find those simply by looking at the degree of the numerator and the degree of the denominator. So those are probably easier to look all the way back up here. In this case, we've got a degree 2 polynomial up top and a degree 2 polynomial on the bottom. So our horizontal asymptote is just going to be the ratio of my leading coefficients, which is a 2 up top and a 1 on the bottom, or just plain y equals 2. Since I have a horizontal asymptote, I know that I do not have a slant asymptote, so I don't have to worry about that. Intercepts, x and y intercepts. The y-intercept, as we have done any other time with a function, is just what happens when we evaluate f of 0. We can plug that into any particular one. I happen to like this unfactored version because 0 squared is 0 times 2 is still 0, so we have -8 up top. 0 squared minus 3 times 0 is all 0, so we just have -4 on the bottom, and we get a 2. Now, depending on your textbook, it might say that that is your y-intercept, or it might want your y-intercept to be 0, 2. Pay attention to your textbook and teacher. But that gives us this point right here. And yes, that point is on the horizontal asymptote. That's fine. We can cross a horizontal asymptote all day long. We can't cross the vertical asymptotes. But horizontal asymptote, we can cross it all day long as we eventually start to look like a horizontal line along that asymptote once we get far enough to the left and far enough to the right. X-intercepts we find by setting the whole function equal to 0, but I claim if we set this equal to 0, our first step would be to multiply both sides by the bottom, and 0 times this is 0, so it's really the same thing as setting the top equal to 0. So we get x plus 2, well, 2 times x plus 2 times x minus 2 equals 0, which means x equals -2 and x equals 2. Again, some textbooks will accept that as the x-intercepts. Some will require that you do -2, 0, and 2, 0. Just pay attention to your textbook and your teacher. And we already determined there are no holes. I left symmetry as an afterthought, but the nice thing is, based on where our asymptotes are already drawn, we can say this is not symmetric. Our choices are even or odd. If it's even, it's symmetric about the y-axis, which means these asymptotes should be the same distance from the y-axis. They are not. It's not even. If it's odd, it's symmetric through the origin, which basically means I should be able to rotate it 180 degrees around the origin and get the same picture. Clearly with these asymptotes, and especially with where that horizontal asymptote is, this is not odd. So we don't have to worry about symmetry, and usually we don't. It's rare that symmetry comes into play. So now it's a matter of graphing this. You might want to select a few more points, but I claim we don't have to every single time. Because we know it eventually has to look like the horizontal asymptote, and right here it has to hit the x-axis when x is -2. So that means it has to come up and approach the horizontal asymptote here. I know that. I don't have to do any other work. I know it has to eventually look like the horizontal asymptote. As we approach this vertical asymptote, we either have to go down or we have to go up. But I have found my only two x-intercepts here at -2 and 2. If I went down, I'd have to go through the x-axis, so I would have to have one more x-intercept. I don't have it. Can't go down, have to go up. So that means I have a graph that looks something like this. I go through the y-axis right here, and as I approach this vertical asymptote, I either have to go down or up. Same argument as before. I do not have an x-intercept in between -1 and 0, so I cannot go down. That x-axis is blocking me, so I've got to go up. These two dots have to be connected. So the only question is, do I go down or up here? Do I bounce off the x-axis or go through it? And do I bounce off or go through it? And in that case, we're basically going to have to test values, but my recommendation is use this one because I really don't care what the y value is. I care whether it is positive or negative. So this one's easier. 3 is in that region that I want, so let's look at f of 3. Well, f of 3 gives me 2 times 3 plus 2 is 5, 3 minus 2 is 1, over 3 minus 4 is -1, and 3 plus 1 is 4. Again, I really don't care what this multiplies out to. I've got a positive up top and a negative on the bottom. This is, what am I writing? This is less than 0, which means it's negative. The y value is negative, so I know here I'm below the x-axis. I know I can't go back up, so we've got to continue down. Finally, I need something in here. How about -1.5? 2 times -1.5 plus 2 is positive. -1.5 minus 2 is negative. -1.5 minus 4 is negative. -1.5 plus 1 is also negative, so I've got negative times negative is a positive on the bottom. Positive times negative is negative up top, so I have negative over positive is negative. So again, we went down and we have our sketch. And that's what it takes to sketch a rational function. Again, you can use the steps, whether it's the 9-step process in Trigstead, the 8-step in Miller, the however many step it is in Blitzer, or whatever college algebra textbook you're using. You can use that multi-step process. In the end, it gets you to this same basic picture. I hope this video helps out.